Lead! Acid! It can burn your face off, and it can blow up! But you know what else? It can start your car. We're talking about lead-acid batteries! So, lead and acid. I already said that. A 12-volt lead-acid car battery consists of 6 cells that each produce 2 volts. Each cell holds 2 thin plates. One is lead and the other is lead dioxide. The plates hang out in an electrolyte bath of about 65% water and 35% sulfuric acid. The cells are connected in series and there's a positive terminal on one end and a negative terminal on the other. When the acid's in solution, the hydrogen ions and the sulfate ions are free to interact with the lead and the lead dioxide plates. The hydrogens bond with the lead dioxide, yielding a lead oxide and H2O. It effectively gives the terminal a positive charge. While this is happening on the lead dioxide plate, sulfate ions are busy bonding with the lead surface, forming lead sulfate and giving that terminal a negative charge. So, when the battery isn't being used, the electrons gather around the negative terminal, and they're not super happy about it either. After all, they are negative. They'd rather head over and balance things out over on the positive side on the battery, but they can't move through the sulfuric acid bath to get there. They need a different path that'll let them travel around to the positive side. That would be a circuit, which is a conductive loop through which electricity can travel. All of your car's electric bits are connected to the battery terminals by the wiring harness, and that makes one complete electrical circuit. When you switch on the ignition, all those electrons stored up in the battery get released. They race out through the negative terminal, through the wiring harness, to power your dash light, stereo, and everything else that runs off electricity. And then they get over to the positive side of the battery. Home at last. The chemical reactions and the flow of electricity can keep going until there's nothing left with which to free up electrons. When the lead plates get completely coated in lead sulfate and the sulfuric acid is diluted with water, well, you got a depleted battery. But one of the cool things about a lead-acid battery is that those chemical reactions can be reversed. And that allows you to repeat the process over and over and over again. And over and over and over and over again. Over and over and over and over. But if your battery loses all its juice, well, those lead plates are coated with so much sulfate that the reaction won't reverse. Some battery chargers have what's called a descaling or reconditioning mode, and that uses a different, sneaky, pulsating kind of current to try to break up all that sulfate scaling, trying to get the battery to accept a charge. But when the battery's done, it's done. But there's some other concerns with traditional lead-acid batteries. When this reaction's happening, sometimes we're producing a lot of gas. If the battery isn't properly vented, well, kaboom! And now that we've got a properly vented battery, well, unfortunately, sometimes that H2O is gonna evaporate. Then it throws off the balance of acid and water. Sometimes you gotta recharge it, which is different than recharging it. You know what I mean. So, how do you make sure that your battery doesn't just run out of juice when you're driving around? The alternator. The alternator gets its name from the fact that it produces electricity in an alternating current. That's called AC. But to get that into the battery, it's got to change it into a direct current, or DC. AC, DC. Woo! An alternator converts some of the mechanical energy from your engine into electricity. The battery is really only there to fire the engine up and run some of the accessories when the engine's off. When the engine's on, the alternator produces all the electricity that your car needs, while also continuously recharging the battery. An alternator is a little AC power generator that's bolted to your car's engine. So how does it convert mechanical power to electric current? Magic. Okay. Here's what really happens. The alternator is driven off the crankshaft by a belt. And that spins a rotor inside the alternator. There's a series of magnets with alternating north-south pole directions that are placed around the rotor. The whole thing is surrounded by a stationary set of copper wires. Now, I know this sounds crazy, but when you pass a magnet over a conductive wire, it makes an electric current, with several magnets being continuously moved over a crap ton of wires inside an alternator. You get quite a bit of electricity. In fact, it makes a lot more electricity than a typical direct current generator does. At idle, cars need more than a DC generator can make, and so that's why we use alternators. Look, a bunch of voodoo hocus pocus goes on in there that has to do with electromagnetic fields and alternating currents. All we really need to know is that a lot of electricity comes shooting out of there, and it's in the wrong format, and it needs to get converted to the right format so that you can operate your power windows. To accomplish that, the AC power is routed to the diodes that stop the current from alternating, effectively forcing it in one direction. The alternator typically makes more voltage than a battery can handle, 13.5 to 15 volts, compared to the 12 that your battery likes to hold on to. Pumping in too much power can fry that thing. So after the AC-DC conversion, a voltage regulator stands between the diodes and the battery to determine how much electricity passes by. With the electrons now flowing into the battery, lead sulfate gets broken back down and the whole process can start all over again. Batteries! This episode of Science Garage is brought to you by yourselves! Guys, thanks for watching. We couldn't do all this cool stuff without you. Tune in every Wednesday. Click this subscribe button so you never miss an episode. Check out the Up to Speed on Nismo. Check out Nolan's Wheelhouse on how to import foreign cars. Check out shop.donut.media. Follow me on Instagram @BidsBardo. Follow Donut @DonutMedia. Don't tell my wife I left the dome light on. I'm gonna blame it on her.